Answer.
Yeah.
Different. Also, okay. I will check the final answer. Which one is mistake? Because this one is from physics study website. No, same result, right? So this one is a little bit different. 7 to 41 should be right. MI is the same, okay, 25.8, right? Delta H is heat of fusion of the ice. The hydroxide, dissolving is equal to heat of the calorimeter minus. Negative sign indicates that the losing energy is from the sodium hydroxide, while the water receives the energy. Water in the column gaining energy. This one is hotter than water. So the result is like this. You get it? Yeah. The water is cooler than the sodium hydroxide. So the water is gain energy from the sodium hydroxide.
How do we know that?
From the problem, the water first, the water is 19.5 degrees Celsius. So the temperature of water is cooler than when we dissolve with the sodium hydroxide. Yeah, same like hot water with ice cube. So the ice cube will gain the energy from the hot water.
Oh yeah.
Okay. For the coffee cup, maybe the final temperature will be lower than the initial temperature of the hot water. But this case, the final temperature will be higher. Yeah, the difference condition.
Because there's an increase in heat, the temperature.
Yeah. Okay.
Okay.
But the amount is correct, but minus, only the minus change. Yeah, we have to know which one is gain the energy and which one is emit the energy. Okay? Okay, good. Thank you.
I have
Yeah.
one question.
This is for you.
Mass of water.
The mass of water. Yeah.
Is it equal?
Because we want to determine the heat of the sodium hydroxide, and the Q will be same. So just measure the water.
Oh, so the volume of the water is equal the mass of the water.
Yeah, because this is like serbuk itu apa? Powder. The powder pour into the solution of water, so the amount of the water will be the same, 100 milliliter.
Okay, thank you.
Okay, thank you. So the next, like this. paraffin candle has a mass of 96 point. Oh, I have more than 3, I think. Gram, a metal cup with 100 milliliter of water at 16.2 degrees Celsius absorb the heat. So it will gain the heat, the energy from the burning candle and increases its temperature. The same condition as before. The temperature becomes 35.7 degrees Celsius. And the paraffin had a mass of 96.14 grams. And then the question is determine the heat of combustion of paraffin in kilojoule per gram. The density of water is 1 gram per milliliter. I just directly show you the answer. Q paraffin, same like the previous one. The water gain the energy, the heat from the paraffin because the final temperature is increased. So Q paraffin will be equal to minus Q water. Okay, same. This is a key calorimeter. So the paraffin will be minus key water. This is the combustion of paraffin. Delta H. If we want to find the combustion, delta H will be like this. Okay? So, check your understanding. This one. A 2.15 grams cashew nut is born. This is for the bound calorimeter, I think. The heat release raises the temperature of 100 gram sample of water from 18.2 degrees Celsius to 31.5 degrees Celsius. The mass of nut after the experiment is 1.78 grams, and the question is determine the calorie content of the nuts in calories per gram. Assume that the water is only able to absorb 25% of the heat released by the burning nuts, given 1 calorie is 4.18 kilojoule. The first step, measure the Q of water, MC delta T, and then the energy. This one, that is the additional information here that the energy absorbed by the water only 25. The previous problem that assumes that all of the energy will be absorbed by the water, right? But this one, there is an additional information like this. So we count the Q of the nut will be divided by 25%. So like this. So the calorie content will be 5.4248 calorie per this burning 0.37 grams of the cashew nuts. Okay, easy. Any question? I will show you the PowerPoint.
Calorie content is the delta H.
Yeah. Delta H. Okay, we'll see the video. Sorry. Okay, I'll show you this. Oh, no. This one.
Here's a familiar scenario for many of us. You purchase your favorite junk food and demolish the entire bag or box in one sitting. Just out of curiosity, you take a glance at the nutrition information on the back of the package, and your full stomach drops. It turns out that you just ate more calories with this one snack than you should in one day. Have you ever wondered just exactly how the manufacturer of the food item knows how many calories it contains? Thanks to calorimeters, manufacturers are able to tell us exactly how many calories we're consuming when we eat their product. A calorimeter is used to measure the enthalpy, which is the heat energy of a reaction. Calorimeters can vary in quality. Simple calorimeters are used in high school chemistry classrooms, but much more sophisticated calorimeters are used in industry. There are many uses for many different types of calorimeters. We'll discuss two of the most common calorimeters and their uses. 1. Coffee cup calorimeter. A basic coffee cup calorimeter typically consists of a styrofoam cup, an insulated lid, and a thermometer through a hole in the lid. It's typically filled with water. Calorimeters measure the energy transferred between the water and the cup and an object that's placed into the water. Coffee cup calorimeters are often used in high school chemistry calorimetry labs. A specific mass of water is poured into the styrofoam cup, and the temperature of the water is recorded. An object or substance is quickly placed into the water, and the lid is replaced. After a minute or two, the temperature is measured again. This change in temperature can be used to find the enthalpy of fusion, the energy required to freeze or condense, enthalpy of dissolution, or the specific heat of an object, the amount of energy needed to change the temperature of 1 gram of the substance by 1 degree Celsius. Each substance has a unique specific heat. A limitation to this type of calorimeter is that styrofoam
I will find another URL. So yeah, the point is we can find the specific heat of the object with a coffee cup calorimeter, but by measure the enthalpy. Okay. Okay. So is there any other question before we close the class today? Actually, I have many problems, but still in Bahasa. For another class, maybe you can see, but still in Bahasa for the problems here. So I will translate, but there is no time